Previously in Matrices 3 we looked at calculating the determinant of a 2 by 2 matrix. In this section we look at calculating the determinant of a 3 by 3 matrix. Now we saw that the unit matrix was defined as having all of its leading elements set to 1 and all the other elements set to 0. And if we multiplied the unit matrix by any matrix, we got the original matrix back again. We also spoke about the determinant of a 2 by 2 matrix, and we saw that this was designated by two vertical lines on either side of the elements of the matrix, and it was calculated by multiplying the product of the diagonals, or multiplying the diagonals, so it's these A times D, and subtracting them. So AD minus BC, or the difference between the products of the diagonals. And this had a unique numeric value. Now, to calculate the determinant of a 3 by 3 matrix, we first need to calculate or determine the minor and the cofactor. So we'll talk about these now. So first of all, the minor of an element within a 3 by 3 matrix is defined as the 2 by 2 determinant obtained by covering the row and the column containing the element. So what does that mean? Let's have a look at this matrix. Let's say we were asked to calculate or determine the minor of the element 4. So what we do is we cover the row and the column containing the element 4, and we get the determinant of the remaining 2 by 2 matrix, which in this case is 2, 3, 8, 9, and we calculate the determinant by taking the difference between the product of the diagonals. So it'll be 9 times 2 minus 8 times 3, which is 18, minus 24, which is minus 6. Now we also need to look at the cofactor, or the sign of a minor. Now the sign of a minor depends on its position within the matrix. And that pattern is given as follows, and it alternates between plus and minus as shown. So let's say we were asked to calculate the signed minor, or the cofactor of the element 4. So first of all, we just get the determinant of the element 4 as normal. So we get this by covering the row and the element containing 4. So we're left with 2, 3, 8, 9. And the determinant of this matrix is 2 times 9, 18 minus 24, which is minus 6. So we now look at its position. So its position is here, which is minus. So we multiply the determinant, or the minor, by minus 1, and we get the signed minor, or the cofactor, which is plus 6. So now we can talk about getting the determinant of a 3 by 3 matrix. And the determinant of a 3 by 3 matrix is obtained by getting the sum of the products of the elements and their cofactors of any row or any column. So this is best seen by means of an example. Here we have a 3 by 3 matrix, and we're asked to calculate the determinant n. So what we do is we pick any row or any column first of all. So let's pick the first row, 1, 3, minus 2. Next we determine the sign pattern for that row, which will be plus, minus, and plus. And now we get the cofactors of each one of these elements, and then multiply them by the elements to give the determinant. So first of all, how do we get the cofactor of the element 1? Well, first of all, we get the determinant of 1, which is found by covering the row and the element containing 1. So we get the determinant of minus 1, 4, minus 2, 7. And this will be minus 1 times 7, minus 4 times minus 2, which is plus 1. And because its sign is positive, it'll be plus 1 multiplied by 1, which is just plus 1. Now let's get the cofactor of the second element, which is the element 3. So we cover the row and the column containing 3. We get the determinant of the remaining 2 by 2 matrix, which will be 2 times 7 minus 4 times 5, which is plus 6. And then we look at its position, which has a sign of minus, and we multiply minus 6 by minus 1 to give plus 6. Finally, we get the cofactor of the last element, minus 2. So we cover the row and the column containing minus 2. Get the determinant of the resulting 2 by 2 matrix, which will be 2 times minus 2 minus 1 times 5, and that will be plus 1. Check its sign, which is positive, so plus 1 multiplied by plus 1 is just 1. So the three cofactors of these three elements are 1, 6 and 1. And now what we do is we multiply each of the elements by their cofactors. So 1 times 1 plus 3 times 6 minus 2 times 1. So that'll be 1 plus 18, which is 19, and 2 from 19 is 17. Let's have a look at another example. Here we're given a 3 by 3 matrix, and we're asked to form a matrix B from the cofactors of n, and then find the determinant of n. Okay, well first, to get the cofactors, we get the minors of each of the elements, and we take into account the sign of the element within the position of the matrix. So for example, to get the cofactor of the first element 4, we cover the row and the column containing 4, and we're left with the determinant of 1, 1, 2, 0, and the cofactor is the determinant multiplied by the sign, which in this case is positive. The next element 2 will have a determinant of 0, 1, 3, 0. The next element 0 will have a determinant 0, 1, 3, 2. The 0 on the second row will have a determinant of 2, 0, 2, 0. 1 will have a determinant of 4, 0, 3, 0. 1 here will have a determinant of 4, 2, 3, 2. 3 will have a determinant of 2, 0, 1, 1. 2 will have a determinant of 4, 0, 0, 1. And the last element 0 will have a determinant found by covering the row and the element of 0, which will have a determinant of 4, 0, 2 and 1. So we write down the corresponding signs of each of these elements, so we'll be alternating between plus and minus as shown, and we work out the determinants and then multiply by either plus 1 or minus 1 for the cofactor. So here we'll have 1 minus 2, which will just be minus 2. Here we'll have 0 minus 3, and minus 3 by minus 1 will give us plus 3. This will be 0 minus 3, which will be just minus 3. This will be 0 minus 0, which will be 0. 0 minus 0, which will be 0 again. This will be 4 times 2, 8 minus 3. And then take into account the sign, which will be minus 1. Here we'll have 2 minus 0, which is just 2. Here we have 4 minus 0, which is going to be 4, and multiplied by minus 1 we get minus 4. And here we have 4 minus 2, which will just be 4. So this is the 3 by 3 matrix formed by the cofactors of the matrix n. Now we're also asked to calculate the determinant. So the determinant is found by taking any row or any column. So in this case I've taken the first row and multiplying each of the elements by the cofactors of those elements. So it'll be 4 times the cofactor of element 4, which is minus 2, so it'll be 4 times minus 2. Then the second element will be 2 times the cofactor of 2, which is 3, so it'll be 2 times 3. And 0 times the cofactor of 0, which is minus 3, so it'll be 0 times minus 3. So this will be minus 8 plus 6, which is minus 2. So the determinant of the matrix is minus 2. So here's another question, or the last question, and you're given a 3 by 3 matrix. So you should have a go at this now. Form a matrix B from the cofactors of A, and then find the determinant of n.